tēnā koutou katoa. Ko Tara Satyanand toko ingoa, ko Cure Kids aho. I'm Tara Satyanand, and I'm responsible for making sure that Cure Kids delivers on big research for little lives. Big research means the most innovative ideas from the smartest researchers using cutting-edge technologies to transform the lives of our children. Morena, and congratulations on your excellent decision to get up very early in the morning to come and hear about some of our highlights from some of our very best researchers. If you know this building, you'll know that the bathrooms are just out here, and you'll see that there's a fire exit here and another one on that side. Should there be any kind of emergency, go down the stairs at either end and congregate just outside in Area J. I hope you've all had a good dose of caffeine and a big glass of water, because you're about to be treated to some serious science. We are very proud to be able to support the work of the researchers you're going to hear from, and very grateful to some of the generous people in this room who enable us to make that happen. So this is our agenda for this morning. As you can see, we've set all of our speakers a very ambitious target of presenting in 7 minutes. But first I would like to introduce Francis Benge. Francis keeps our focus on achieving our mission of transforming health for the children of Aotearoa, New Zealand.
Thank you, Tara. I'll just place the essential items on. So, inga mana, inga waka, inga reo, e rā rangatira mā. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Thank you so much for getting up early this morning to hear what is a real highlight in the Cure Kids calendar and profiling all of our beautiful research for little lives. For more than a year, we've had an extraordinary public spotlight cast upon the incredible work of health scientists, epidemiologists, vaccinologists in the face of the global pandemic. Cure Kids shares the same relentless drive for the prevention, treatment and cures, not just for one condition, but for all of those serious health conditions affecting our tamariki. Sadly, in August last year, the man who founded Cure Kids passed away in his home, aged 86. And right up until the night before he died, he was ringing and emailing me saying, "Francis, I've got a bucket list that I need you to achieve." So Professor Bob Elliott had the visionary foresight to know that unless we started investing specifically in child health research in New Zealand, our health stats would drop significantly in the OECD rankings. Professor Elliott and co-founder Sir Ron Coe established the Child Health Research Foundation with very generous support from Rotary. Now known as Cure Kids, the organisation has become one of the largest funders of child health research outside the government. This year we celebrate our 50th anniversary, and the passing of our beloved Sir Bob has given us an even stronger drive to continue his life-changing work. We carry this precious mantle with us today. We're passionately focused on funding research into those health issues which are preventable and as a result of social deprivation and inequities in our country, frankly with some statistics that we should be ashamed of. Today we'll hear from some of our incredible researchers whose dedication to finding cures, causes and treatments is supported by you. And what excites me most about our researchers' work is the potential for any New Zealand-derived research breakthroughs to actually translate into international impact as well. And some of the work you're hearing today does that. Imagine if our Kiwi researchers could find local, groundbreaking solutions for child health and then impart that knowledge internationally where the same health issues are rife. Despite Cure Kids taking on some really scary and difficult stuff, my spirit grows really hopeful when I witness the generosity and empathy of everyday Kiwis like yourselves. Not that you're every day, you're pretty special to me. Cure Kids noticed a significant trend towards the end of 2020 where public philanthropy suddenly picked up. Perhaps it's from a year of realising the vulnerability of our health. And while some of us are blessed with really good health and we're blessed with beautiful, healthy children, I think what was poignant for us was that we maybe had to put up with a lockdown for a few weeks, but some of the children that we're looking for solutions for, who are immunosuppressed, face a lifetime of lockdown. So to reflect on both previous and the next 50 years of our work, on behalf of everyone at Cure Kids, I want to acknowledge all of you supporters. You've made our funding possible, and I want to thank the dedicated researchers with endless questions to solve, and also the brave children who are at the heart of our cause in the first place. And I'll show you a little video in a few minutes of Ben, who's one of our fabulous kids. Together we should be so proud of what we've achieved in the past 50 years and the huge impact that has been made on child health in New Zealand. But there is so much more that we can do, and we can only advance our vision with the unwaning support that you give us. So stay with us in the waka to truly make a difference to the health of our tamariki with big research for little lives. Hori noa e te whare, tēnā koutou katoa.
Doesn't feel most of his legs, so the fact that he can do this, I don't know how he does it. So here we go.
Wow, that is so cool.
Oh, let's get off the carpet. There we go. I'm Catherine, and this is Ben, and this is my little boy. And at my 20-week anatomy scan, I found out that there was a severe deformity with his spine and brain. This led to a diagnosis of Spina Bifida myelomeningocele at level 3, so his L3 was open all the way down in his spine, so there's a big opening in the spine. And he also has hydrocephalus, which is the swelling of the brain. So he was our second little baby, and I guess we were so surprised. I mean, you go to these scans and you only really hope for the best and a healthy little baby, and you get told that there's something really wrong with their brain and their spine. You don't really want to hear, so it's an incredibly stressful time. There's quite a few associated symptoms, so they have issues with their gross motor skills and sometimes cognition. Usually for this condition you do a big surgery when the baby's born and they close the spine up, and they might put a shunt in soon after that in the brain. He was the first Kiwi to have fetal surgery, so when I was 24 weeks pregnant, so he was only 24 weeks gestation, they operated through me and closed up his spine. And then he had some brain surgery where they inserted a shunt because they did an MRI and actually found that he was born with a syrinx in his spine, which is a huge fluid-filled cyst, which if it presses on a nerve can actually cause more numbness or tetraplegia. So that was put in when he was 34 weeks, so he was a week old at that time. So quite big surgery for a little tiny baby. He uses a lot of energy to walk and use those muscles. It's just tiring for him. He has to think about every step he takes, every little movement it takes to walk or to move. When we walk, it's nothing. To him, it's like a marathon. So he's like doing a marathon nearly every day, trying to get these muscles going. Hydration is super important for his bladder. So we've got to keep him, he has to have a lot of water so that it's constantly clearing itself. He only drinks water, I mean sometimes milk, but no, it's water. So water is super important. There's not a lot of Spina Bifida in New Zealand. Most people terminate. So because of that, there's not a lot of material or people to kind of go to. And we've had so much help from Cure Kids and from just the medical industry here. It's just nice knowing that yeah, in some way someone's kind of been through something similar, and you can talk about it and just see they're beautiful children from all walks of life. They give us, like, our little family hope, basically. The platform that they can provide for just awareness and, like, Spina Bifida and hydrocephalus and all these other conditions, all these other kids and families. If we can get like one investor or one researcher just to show some interest in a particular area, you know, the sky's the limit with what can be done with these children.
So thank you. Thank you for hanging.
Thank you for hanging.
Hanging out with me.
Hanging out with me.
So that was Baby Ben. Thank you very much, Francis. And now it is my very great pleasure. Oh, this is our agenda again in pictorial form. And I should just note that instead of Dr. Siobhan Cross, we'll have Dr. Amanda Leiber presenting about child cancer. But first, it is my very great pleasure to introduce Emeritus Professor Brian Darlow. He was first made the Pediatric Chair here in Otago in 2001. And from 2007 to 2018, he was the Cure Kids Professorial Chair of Pediatrics here at the University of Otago. In his career as a clinical neonatologist, Professor Darlow has cared for thousands of children, but he has also asked the really big questions about how to improve care for our very youngest New Zealanders. His research interests have focused on newborn babies, looking at things like free radical disease and neonatal networking, and also complications in preterm babies, how to understand those, how to improve care, and how to improve outcomes. So without further ado, I will hand to Professor Darlow. Sorry, I'm realising I don't have that on.
So thank you, Morena. Thank you very much for that kind introduction, and welcome to this meeting. I'd like you to meet Bill and Ben. These are very preterm twins, born to the same parents. They have the same sporting allegiance, Canterbury of course, but very different health outcomes, as you can see. And I'd just like to remind everybody that we are of course all different. We know that, but that applies to the very preterm community as much as anything else. We're products of nurture and nature, genetics in the environment. These shells were all picked up within a few yards of each other on a beach of Coromandel. So what we're talking about is babies who are born very low birth weight, that's less than 1,500 grams, or very preterm, that's less than 32 weeks gestation. They're not quite the same groups, but they're very comparable. And they constitute just under 2% of live births. And the numbers have been increasing, so doubled between 1986 and 2008. And survival has increased as well, as is shown by this wonderful data over 50 years from National Women's Hospital. But everybody is interested not just about survival, but the quality of survival in the long term. Now we know that in childhood, very preterm graduates have quite a lot of problems. Up to 10% will have neurosensory impairments, particularly cerebral palsy. Up to 40% will have behavioural problems, cognitive delay, education underachievement, and there are general health problems, often leading to admission to hospital, particularly respiratory problems and feeding problems. But much less is known about the much longer term outcome, particularly to young adulthood. The data we have is emerging from national registry data, particularly from Scandinavia, where they do things like that very well. Very large numbers involved, but the data lack important details. There are some wonderful hospital-based cohorts, particularly from Canada, McMaster and Montreal, and also Helsinki, and some data relating to individuals admitted, included in a number of trials. And then there are population-based data. New Zealand and the Netherlands, the only two countries that have national data, but there's a younger cohort emerging from the UK. So we're talking about births now from the 1970s and 1980s. And recently there's been an international collaboration of these studies called the Apec Collaboration. The New Zealand cohort includes all very low birth weight babies who were live born in 1986. And they were entered in a prospective audit of a condition called retinopathy of prematurity that leads to visual impairment and potentially to blindness. And that cohort was followed up at 7 to 8 years of age at time of a home visit, and then again at 22 years with a face-to-face questionnaire, and then at 26 to 30 years. And at that latter follow-up, 250 graduates were seen and 100 term-born controls, and 229, the very low birth weight, and all the controls came to Christchurch for 2 days of investigations. Everything that we could pack in to 2 days, limited only by time and funding. At both the adult times, the participants answered a questionnaire that included questions about physical and mental health and social functioning, life satisfaction and self-esteem. And at 22 years, the very low birth weight group had lower rates of tertiary education and training than the controls. There were fewer in paid employment. They were more often living with their parents. They had fewer friends, less engagement in sexual partnerships. But very interestingly, they regarded their life satisfaction and self-esteem no difference at all from the term-born controls. By 26 years, the gaps had decreased. Gaps in tertiary education, employment or welfare dependence were reduced. Living arrangements were much more similar to controls. Peer, sexual and partner relationships differences remained, but rates of pregnancy and parenthood was similar to controls. And self-esteem measures, there was still no difference. There now was a slightly poorer quality of life score, and that related mostly to physical issues, and particularly in people with cerebral palsy. We also measured general cognitive functioning, otherwise known as IQ. The important thing to look at here is the figure in the red circle. So after adjustment for various features, the mean difference between the groups was 9.4. And on logistic regression, maternal education strongly predicted verbal and total IQ. Birth weight strongly predicted perceptual and total IQ. And there were contributions from other factors, including the duration of breastfeeding. IQ measured at 7 to 8 years strongly correlated with that at 28 years. So this slide summarises physical health findings, and there were some differences. The very low birth weight group on average were shorter, they were lighter. There was little difference in BMI, which tended to track with societal patterns. They had raised systolic blood pressure, decreased peripheral artery distensibility. That means they had stiffer small arteries. Echocardiograph changes suggested smaller, slightly stiffer hearts. They had increased airways obstruction, the sort of changes you see in asthma, and they exercised less. I think the important thing is that all the mean values for the very low birth weight group were in the normal range, but slightly skewed, if you like, and taken together, these findings suggest the very low birth weight group might be at risk of early onset for chronic disease. Now, we all reach peak function of most organs around about the end of the late 20s, and thereafter it's downhill. Sorry, folks, but that applies to everybody. And that's affected by various factors, nutrition, education, lifestyle choices, etc. So, for instance, on the top, if it's respiratory function and you have a normal decline in function, that might be line A. But if you're a smoker, that might be line C, and you get into problems at an earlier age. We know that very preterm people have a lower peak function for most organs, but we know very little about the trajectory after that. There has been, we know there's great variation in biological aging, and there's been interest in trying to calculate somebody's biological age because that might predict their mortality and morbidity. And the Dunedin Health and Development Study had these 10 physiological data points, biomarkers that they selected that changed with age, and they used a mathematical algorithm to calculate a biological age. So the participants were all 38 years, but the biological age varied from 30 to 50 years. And interestingly, those with an older biological age were looked older, and they tended to have more cognitive decline. So we wondered whether the very preterm infants were physiologically older than controls, and secondly, whether their pace of ageing was comparable or accelerated. And we hypothesised that having a summation score of physiological factors that changed with age, that they might be deemed to have a more advanced physiological age. The factors we chose were very similar to the Dunedin ones that are available to us. But here, for both the very preterm group and the control group, the data were compared with a reference group, and as far as possible, that was from a large population-based sample with a normal distribution and of the same age and sex. And for each marker, we calculated a Z-score. That's essentially the standard deviation above or below the mean. For biomarkers that declined with age, the plus and minus scores were reversed, and then we simply added these together. And we looked at various ways of correcting the data. For all comparisons except one, creatinine, the unadjusted mean Z-scores were higher in the very low birth weight than the controls. And this is the summation score, which was shifted significantly to the right, and that represents a shift of almost a half a standard deviation. So the very low birth weight group were indeed physiologically older than the controls. And correcting for these various factors changed the numbers a wee bit, but not the conclusion. Despite a clear-cut result, the summation score is clearly arbitrary. It hasn't been validated in other cohorts, and it really doesn't tell us about the pace of ageing. We'd have to repeat the score after a period of time to do that. So what we're intending to do with our international collaborators is to see if we get the same results in other cohorts, to calculate an aggregate score, put all the data from all the cohorts together and see if we get the same result, and then ultimately to repeat this after a period of time to look at the pace of ageing. So to conclude, and I think the most important message is the majority of these very low birth weight young adults are living healthy, productive lives similar to their peers. But biomedical measurements are mostly in the normal range, although the group is on the worst side of the ledger, if you like, compared with the controls. And a summation score suggests the very low birth weight adults have a more advanced physiological age, but as yet the pace of ageing remains unknown. We probably need to consider very preterm birth as a chronic condition and recognise that these adults might be at risk of chronic diseases in middle age, and so they need ongoing health monitoring. And it's very important that these individuals are encouraged to adopt healthy lifestyle choices from an early age. Now, I just want to finish by acknowledging a lot of people. Many people have been involved in this study. On the top left is Sarah Harris, who's taken over as the lead investigator for the study, and together with Richard Troughton, lead on cardiovascular outcomes. John Horwood is a biostatistician involved with the study, has been since the 1980s, and it's absolutely true to say that without his involvement, the study would not have happened at all. Leanne Woodward leads on the psychometric data. Yun Yang and Michael Epton lead on respiratory outcomes. Vicky Cameron, who's sitting up in the back of the room, is looking at epigenetic changes related to cardiovascular outcomes, both in the adult blood and in archival hill prick samples taken soon after birth. And Tracy Meltzer is leading on cranial MRI studies. And of course, I want to thank the funders, the principal one being Cure Kids, who've been extremely supportive of this project and generous to me over many years. We also had a project grant from the HRC and support from many other sources. So thank you very much.
Thank you, Professor Darlow. Now, I'm sure there are many questions as a result of this, but what we're going to ask you to do is wait, and at the end we'll all have coffee together and you can ask questions at that point. Now, next I have the pleasure of introducing Dr. Lucy Daith. Dr. Lucy Daith works at the Canterbury District Health Board, and after the earthquakes, the Christchurch earthquakes here, in supporting families and children and young people, she embarked on a research project with Professor Sally Merry at the University of Auckland. Sally Mary is another professorial chair with Cure Kids, enabled by generous funding from the Duke Foundation, and her work focuses on children and young people and mental resilience. And Dr. Daith's going to tell you about some very sophisticated science, which has resulted in a deceptively simple solution to support families through difficult times and improve mental health for young people.
Tēnā koutou katoa, kia ora, Tara. Ngā mihi nui ki a koutou. Kākano means seed, and this project was about designing an online intervention to support and grow family wellbeing for families with kids aged between 5 and 12. And there was a feeling that families in Christchurch were under significant pressure after the earthquakes, and that the primary aged kids were particularly vulnerable to this distress. So this project was, as said, funded through the generosity of Accor Hotels, and we were really grateful to receive this out of the blue, and Cure Kids, and we worked closely with Sally Mary and the team at the University of Auckland, and we began work in 2018. So Kākano is about growing good families, and we started by talking to a whole bunch of parents about what family life meant for them and how it felt, what they loved and what they found challenging. And they told us that life was busy and that there was lots of juggling, and they told us that they loved their kids, but that they really wanted their kids to be happy and fun and caring and kind. And they told us that sometimes their kids' emotions went from woe to go for apparently no reason in 5 seconds, and they could suddenly be really angry or worried or scared, and these big emotions seemed to come from nowhere, and they didn't really know what to do about them. So they struggled to understand what was escalating so fast. So this was about growing the kind of families that people wanted, and you can see that we use very simple pictures and scenes from New Zealand life, and invite people to think about what kind of family they want to grow, whether it's a caring or adventurous or fun or active family. And so each week the family sits down together after they've registered, and they decide what they want to work on together, and they set up some goals that they want to adopt. So practice through the week to help them do things together. And then they can kind of print this out as a weekly sheet and put it on the fridge, and meet at the end of the week and see how it's gone. The goals are around tika, pono and aroha, doing things right, doing things with honesty and authenticity, and doing things with love. This is the constituents of mana, and the Māori we talked to said that that's at the heart of mana, that's at the heart of good family life, so that's what the goals fit through. And then at the end of the week, the family can meet and say, well, how did that go? We were going to invite someone round to share kai. Did that go, or did that not go? We all had a cold, so we didn't invite someone. We could try that again next week. And regardless of how they mark it, this vine keeps growing, and it keeps growing with some little critter facts, which parents told us kids are really into the critters, and so these are native critters that you might get a little fact about. And there's also a section called Coolers, which is where parents can read some background and some tips about what might work when kids are really angry or sad or scared. And when those big emotions run through, what can we cool things down with? And these are based on the best evidence psychology, and although we've written them in quite lay words, like things are amping up or dial up the uffy, we've got them checked with a psychiatrist from CAF to make sure that we didn't lose any of the active ingredients as we worked. And there's also an inbuilt timer, because taking time out can be encouraged for everyone in the family, and we know as parents that sometimes just going and making a quick coffee can be what it needs to cool things down. And so we encourage that everyone in the family could do that. We tested Kākano using a randomised delayed access waitlist control trial, which means basically some people got it immediately and some people had to wait a month to get it. We worked with 2 Kahui Ako clusters, that's school clusters across the city, and we tried to match them for deciles of schools and number of Māori and Pacific families, and whether they were rural or urban. So we had 2 kind of balanced groups of schools, and we advertised the trial app through the mana ake workers who are based in schools who had relationships with some parents. And parents who signed up either got the program immediately or waited a month. And the impact was measured through a whole range of different scales and a satisfaction survey asking people what they liked, and through the back end of the computer seeing how long people had used the app and for how long. And overall we had 230 participants enrolling and 70 completed the trial. It's really hard to get people through to the end of these trials. This is what Sally Mary tells us. But in the end, what we found was that there was a significant rise in this highlighted one, the Brief Assessment of Parenting Scale, which means parenting skill and confidence significantly raised after using this app. And we were very, very close on the Warwick-Edinburgh mental wellbeing scale. That's a scale of how well the parents felt after using the app, really close to getting that to significance. So although it's a really small trial, it's robust and it's very promising, and parents liked the app and it helped them grow their skills and confidence. And it's great to see this in their own words. Now, I don't have to stress over the housework. Yeah, I haven't been yelling and screaming. It's been good. Why do we think this works? We think that the local look and feel, the te reo and the scenery and the critters make a difference. There's not much that's grown here. We often use Australian or British stuff. It's quick to use, and you can take longer if you want to. There's some engagement for the kids. They can put stickers on, they can give their parents or siblings stickers, and the animals engage people, but there's hard science behind it in chunk-sized bites for the adults. And it provides some practical structure for caring in an unstigmatised way. Next, we'd like to make the app widely available to people because we know it works, and we're kind of at that impasse where we'd really like to talk to anyone who can help us get it out there, because we really want to support parents to grow their confidence so that our tamariki can navigate those big emotions a bit well. So thank you very much, Kia Kids, for the breakfast and for this opportunity. Nō reira, tēnā koutou katoa.
Thank you, Dr. Daith. Now I'd like to introduce Professor Andrew Day, who is our current Cure Kids Professorial Chair here at the University of Otago. And Professor Day leads a very active research program in the field of gastroenterology and leads a team of researchers, including Dr. Angharad Hurley, who I'll introduce after this.
Thank you, Tara. Thank you, everybody. Good morning. So many years ago, Hippocrates is said to have said these things, that basically that the guts are pretty important for all of us. Bad digestion is the root of all evil, for example. More recently, it's very clear that the microbes that we interact with in our daily life are very important in terms of priming the immune system in children, and even more so are important for all of us as we get older. And this statement that was from just a month or so ago from the New York Times, many of the major causes of death in the US are related to poor microbial health, related to dysfunction in the gut. And many of the things that Brian mentioned earlier are included in that list, and the microbial community contributes to all that as well. So all of us have many, many bacterial cells, at least the same number as in our human body, and all of us have a different profile, a fingerprint, if you like, of our bacteria that reflects where we were born, how much breast milk we had, and so on and so forth. And for for me and my team, we're interested in terms of the bacteria, but also in terms of how they interact with the gut, as illustrated here, and particularly in terms of when things go wrong in the gut, such as this condition called Crohn disease. And this is some illustrations of children with ulcers, the area on this side where it's red and raw with a great big serpiginous or snake-like ulcer, with other changes beneath the surface as seen on the far side. And we know that the bacteria are very important for this condition, genes, the immune response, and many environmental factors, including early life events, bacteria, what we eat, and so on, are all important in terms of why some people develop this and some people don't. Our data is illustrated across the age range that this is increasing more and more in Canterbury. And in 2014, when we looked at this report, we were right up, unfortunately, at the top of the world rankings. Not a ranking we really want to be at. That is to illustrate that in children in Canterbury, over a 20-year period, we're seeing 4 or 5 times as many children every year with this condition. So my work, and I'm really giving an overview, is looking at those microbes, at the bacteria, how they interact with the lining cells in the gut, in terms of trying to help us understand the causation of inflammatory bowel disease in children. We're looking at the patterns of IBD, as per that graph, the figure that I just tried to show, with local, international and national studies in informing us in terms of what happens over time, how does IBD impact upon these children. We're looking at better ways to detect and monitor conditions, looking at biomarkers and trying to look at new novel markers to get us better information. And furthermore, trying to understand better ways to manage and treat inflammatory bowel disease, and Crohn's disease is one of the main types of them. As with many of the things you're hearing this morning, this is a team effort. And we can have one of these little squares being cure kids, we can have one of these little squares being the supporters in terms of yourselves. I'm just one part of this puzzle, one part of these pictures coming together, and my team that works with me locally, nationally and internationally working together is another part of this puzzle that's helping to understand and advance how we manage children with these conditions. I'm going to hand over now to Ang Harrod, who will tell us a little bit more about some of the things we've been doing.
Thank you. Do they all run together, do they? Oh, excellent. Okay, so as Andrew was saying, inflammatory bowel disease incorporates the condition of Crohn's disease and also something called ulcerative colitis. And Andrew and I have quite a varied programme of research that we're doing, so I just thought I'd give you an overview of one particular one that we're looking at of ways to improving outcomes for children with IBD. There's no current cure for inflammatory bowel disease, either for Crohn's or ulcerative colitis, so the main aim of clinical management is to reduce disease activity. And disease activity relates to the level of inflammation in the gut and all the symptoms that these children experience. And disease activity, be it prolonged or in a short-term time frame, has a negative impact to these different clinical and non-clinical outcomes. And not just in the here and now, but also their longitudinal outcomes. So, for example, if children miss 1 day in 5 of school, over time, their educational achievements will be less, which will impact their place in the workplace as well. Also, their quality of life, their psychological outcomes will be impacted long term. Their nutrition and growth, they might not reach their full adult growth potential. And in terms of their long-term health, if they have prolonged disease activity and inflammation in their gut, they're at higher risk of needing surgery as an adult, and also things like colon cancer. So we're looking at ways that we can improve disease activity. So obviously you have the clinical side that Andrew does, which is in terms of providing drug treatments. But there's a new approach which is shown to be very successful in other chronic diseases for children and also for adults with IBD, but it's a very emerging concept for children with IBD. And it's something called self-management, and this is all to do with children developing health autonomy for the tasks that it requires to keep their disease under control, but also gives them a sense of control over their own disease management. Now, very brief overview. Self-management incorporates these 4 different factors, and there's a huge degree of interplay between them. So it's about children learning how to monitor their symptoms and being able to recognise changes over time, be it relating to starting new drugs or when they're coming into disease flare or being in remission. It's about knowing disease and treatment knowledge, and you can imagine how these all work together. If children can understand more about why they need to take their drugs, then they're far more likely to adhere to them. And again, looking at symptom monitoring over time and knowing more about their disease improves their communication, which could be with their clinical team, with their parents, with their school teachers. So these all work really closely together. But it's not enough to just want children to achieve self-management skills in these areas. We need to be able to assess them. We need to be able to see where some children might need additional education or additional support. So in the last couple of years, so obviously the central bit when they're managing all of these different aspects is self-management. In the last couple of years, Andrew, myself and Professor Richard Geary have developed a series of assessment tools that we've tested across the world for measuring symptom monitoring. We developed a pictorial scale where children can score their IBD symptoms, and this correlates very well with what the doctors use in clinic. We developed a self-management skills assessment tool, which is all about children scoring their allocation of responsibility for different self-management tasks, and we developed a knowledge assessment tool to find out where these gaps in knowledge are and how they might be affecting the other factors like adherence and symptom monitoring. So I was going to give you a quick overview of the different projects that we're doing related solely to self-management, because like I said, we do have other ones as well. Now, talking about transition outcomes, children and adolescents with IBD have notoriously bad outcomes when they transition from the paediatric teams to the adult healthcare teams. Their adherence drops, not just in terms of taking their medications, but also they don't turn up to their appointments, they don't turn up to have their blood tests, and they don't partake in their ongoing monitoring, which is obviously very important to recognise when their disease activity is rising again. So we want to see whether implementing structured guidelines in hospitals in New Zealand, and hopefully we'll be able to do this internationally, and by doing these measured assessments at particular time points actually improves their outcomes by recognising when they need additional input. We're looking at a study to look at the interplay between these clinical and non-clinical outcomes, like I showed you at the beginning, not just looking at disease activity, but how this affects things like their quality of life, how adherence can improve, levels of anxiety by bringing their disease activity under control, and other psychosocial factors like resilience, not just for the children, but looking at the parents and among the siblings as well. The knowledge assessment tool that we've developed, we have tested it extensively in various countries around the world. Because self-management is quite a new concept, all of these things that we developed are very new. So we are testing them in different countries. We've been testing them in Canada and Australia and New Zealand. We're also starting to test the knowledge levels of different health professionals that come across children with IBD, because all of these play into them being able to improve their outcomes. So that's things as GPs being able to make more rapid diagnoses, the nurses on the wards, pharmacists, medical students. We've also started a series of translation studies to get these more widely known. We've just completed studies developing it into Hebrew and Arabic, so now we want to start doing it into the languages that are more common around the world, so French and Spanish, and when we know that our methodology works, we can become more widespread. Now, all of this information we've learned about the importance of self-management, we've put into one particular place, and we've developed a mobile health app that's very specific at teaching children how to learn self-management skills. And we're going to be starting a study soon. This has been quite a long time in the making, as Jordan will know. So we'll be doing a study to look at efficacy and also engagement and satisfaction, because these wonderful things that we developed are only as good as the number of children that actually use them and find them useful. So the app that we've developed is called Ibd Tracker. Sorry about that, yeah. And it's a very interactive app. It's really exciting. We think it is. And it's all to do with children being able to input interactive data relating to their IBD and self-management, and then they can go back and review their data over anything from 7 days to 6 months, so that they can use this as a communication tool, as a self-management tool. You can imagine a child who's 16, who's just starting to have appointments on their own without their parents. They'll be able to review their data and they can communicate this to their clinical team. So on the left-hand side on these slides, I've put what they input and how they can review it. So for this one, for example, pain, they can report whereabouts in their body they had it, the severity of the pain, and they can go back and look at a graph and the location, so they can see where they're having these repeated symptoms. They can do it for their stool output as well, in terms of what time of day, what consistency, how fast they had to get there, and whether it had any blood in it. And again, these are really important metrics that they need to be reporting to their clinical team, to their parents, and especially when they're learning how to self-manage. In terms of their health metrics, we've got how tired, how poorly they feel, how sick they were, how much they're managing to eat. Very important aspect is being able to help these children adhere to their drugs. So we've got a huge thing that we can do in terms of setting reminders for their drugs, but not over that. They can mark whether they've taken them, they can snooze it if they're playing football, whatever they're doing, and again they can go back. So you can imagine if they're monitoring their symptoms, but they also see that their symptoms are getting worse, but they're not taking their drugs as often. This all connects with them being able to learn what they need to be doing to self-manage their disease, and again gives them this wonderful sense of control. A lot of these children have nutrition drinks, so they can keep an eye on this. They put in a total amount they need for the day, and each time they input a bottle, the body fills up, and they can see how often they're achieving their goal. They can monitor their growth over time, and there's various other sections. So they can set reminders for hospital appointments, whether they need blood tests, their infusions. They can look at whether they've got certain IBD triggers, which again they can relate back to their symptom severity. There's a traffic light system as to when they need to get help in terms of what symptoms might be getting worse. They can all keep track of their own personal disease history in terms of what drugs they're on. So especially for the adolescents who may be becoming more independent, if they have to go to hospital as an emergency and their parents aren't there yet, they'll be able to flash up their own disease history to be able to communicate with their medical team. And we've got a lot of static pages related to knowledge. So they're learning about their anatomy, the different tests they might have, the different drugs they're on. So we've taken this big bank of knowledge that we've been gathering over the last few years on the importance of self-management, and we've put it all into these different research studies that we're doing. And just on the last slide, we do have other studies ongoing as well, but they're not directly related to self-management, but we're looking at the cost of managing children with IBD to determine whether the allocation of resources is appropriate. We're looking at diagnostic delay to see whether the delays in children being diagnosed with IBD are relating to patients and parents. Are the parents not knowledgeable about the first signs and symptoms? Whether the GPs need improved clinical pathways for referral, and whether there's tertiary factors relating to the infrastructure. And we're also doing studies relating to vitamin D and iron infusions and things like that. But thank you to Cure Kids for their ongoing support.
Thank you, Dr. Hurley and Professor Day. I think everything you've heard so far is a testament to what can be achieved through Cure Kids funding of professorial chairs, these big long-term programs of research which are really able to delve deep into an issue and which are really cutting edge internationally. We're also really proud of the fact that every year we run this amazing contest and we ask researchers from all around the country to send us their very best ideas. And because Cure Kids covers all health areas, it could be on anything. And so last year, when we had our contestable round, we had an outstanding application from Dr. Samantha Murray at Lincoln University. She's a neuroscientist and she's working on a rare disorder called Battens Disease. And she's using a sheep model to help understand more about how the disease works, how to care for children, and potentially how to find that elusive cure, a gene therapy. Thank you, Samantha.
Thanks, Tara, for the introduction. So I'll just jump straight in. Battens disease is a neurodegenerative disease that primarily affects children. So there's many different forms of this disease, but they're all quite similar in how they present. So basically neurodegenerative means that the cells in the brain die away and the brain tissue shrinks. So children with this disease might develop normally for the first few years. They might get off to primary school. They might start having learning difficulties. They might have behavioural changes. And then they start to lose their vision, they have mental decline, motor dysfunction, they'll start having seizures, and just all of their functions go downhill until they'll die prematurely, maybe in their teens or early 20s. And at the moment, there are very few treatments for this disease, and most of the treatments relate to specific symptoms, and there is no cure. So out at Lincoln University, we have a very unique flock of sheep that naturally get a mutation in the CLN5 gene, causing them to have to get a form of CLN5 Battens disease. So the reason that we like studying sheep for brain diseases is that they have a much similar brain to the human than a mouse. So you can see the tiny mouse brain there, and it's smooth on the surface, whereas you can see that the human brain has all these convolutions that we call the sulci and gyri, which is where all the brain cells live. And you can see that in the sheep brain they also have this. So it looks very similar in terms of body weight and brain weight. They're much similar to the human as well. So these sheep with CLN5 Battens Disease have a well-defined pathogenic cascade. So even from birth, they have neuropathology. So they've got inflammation in the brain, and they've got what we call the storage body accumulation. So this is kind of one of the hallmark pathological features of the disease, is this accumulation of protein in the cells. And so by about 6 months of age, they're starting to have some cell death in the brain. Then they go on to lose their vision. They'll have motor symptoms, and potentially at very end-stage disease, they'll have seizures. But for us, that's sort of a humane endpoint for them. And it's quite an extreme example, but you can see over here, this is a normal healthy brain of a sheep at 2 years of age, and this is an affected brain. So you can see that there's been a huge amount of shrinkage in that brain tissue. So what we're doing with these sheep is basically, it's called gene therapy. So when the sheep get this mutation in CLN5, basically their CLN5 protein doesn't function as it should, and their gene doesn't function. So what we're trying to do is basically give them back a functional copy of that gene so that they can make functional protein and their cells can function as normal. So what we do is we use a virus, and so we take all the virulent DNA out. That's all the stuff that would cause disease usually with a virus, and we basically take advantage of the envelope of the virus, which allows it to get into cells and to replicate. But what we do is we put in our gene of interest, so our CLN5 gene, a functional form, and basically that can then get into cells, and that those cells can start making a functional copy of the protein. So what we've done previously is injected this gene therapy into the brains of sheep. So we go into the lateral ventricles, which are the fluid-filled spaces in the middle of the brain that contain the cerebrospinal fluid, which bathes the brain and the spinal cord. So when we inject this into pre-symptomatic sheep, so sheep at about 3 months of age, we find that we can protect against neurological disease. So these sheep, we've had these sheep live up till 5 years of age when they wouldn't usually live past 18 months. But these animals are still going blind. So they're going blind at a later time point than what they usually would without treatment. And we think that's because we are sort of rescuing the visual cortex from any kind of degeneration, but the cells in the retina are still degenerating. So they will ultimately go blind if just the brain is treated. So to remedy this, we started looking at eyes, and we did a pilot study where we injected our gene therapy into the vitreous of the eye, which is basically just the jelly of your eye. And these sheep got no brain treatment, so although they did ultimately get disease, we were able to protect vision and protect the retinal cells in that treated eye. So then what we really wanted to do was bring these two treatments together and actually try and improve outcomes in terms of both cognition and vision, and particularly if we're thinking of children with this disease, that's really important for quality of life. So we did a combined therapy where we injected into one eye and also into the brain. We did this at 3 months of age, which is pre-symptomatic. We did it at an early symptomatic time point at 6 months of age, and also at 9 months of age when the sheep have advanced symptoms. And so the point of this was that children with Battens disease often aren't diagnosed until they have symptoms, so we really want to be having a treatment that's optimised for symptomatic sheep or children. So there's a couple of graphs here that are quite busy, but the take-home message, we do this clinical scoring on our sheep, which has 10 domains, covers vision, auditory function, sensory function, motor function, and they get a score out of 40. So the blue line along the top is our healthy control sheep, which are always scoring 40, and the red line is affected sheep, which decline in their scores over time. And hopefully what you can see is that in all of our treated groups, they remain pretty stable over time. And then in terms of their brain volume, we did MRI scans on these sheep. So control sheep, nice healthy looking brains. These are the lateral ventricles in the middle here. In affected sheep, you can see that over time, and by the time they get to 18 months of age, these ventricles have enlarged hugely. So this is due to a loss of brain tissue, and you can see that even around the outside of the brain, the cortex here, there's been a huge amount of shrinkage. But in our treated sheep, they actually look pretty good. So although they don't, at 18 months of age, they're not quite the same as controls, you can see that they haven't actually changed over time since they've been treated. So that's really good. They've got stable brain volumes. And this graph on the left is another very busy one. It's to do with their vision and a visual assessment that we do on them. So what I want you to take home from this graph is the dotted lines here are the untreated eye, and the solid coloured lines are the treated eye. And so hopefully what you can get from that is the untreated eyes decline in their visual function over time, whereas the treated eyes are doing a little bit better. And then when we went and looked at the brains of these sheep at 2 years of age, so this is this lysosomal storage I was talking about. So basically the more green dots here, the worse it is. So you can see in the controls there's nothing. In the pre-symptomatic animals, they would have had this amount of storage when they were treated, but you can see that it hasn't got any worse. And again, early symptomatic, they will have accumulated some storage in their cells, but it hasn't got any worse. And the same with the actual, so this is a kind of a cross-section through the cortex of the brain, and these are all the brain cells. So you can see that in affected animals, the brain is a lot smaller than normal healthy animals, and in these guys, the brains are looking pretty nice and healthy too. And so what we're doing now, that's kind of gone a bit skew with, what we're doing now with the support of Cure Kids is doing another study using this dual route of administration, and we're really trying to refine the age of treatment and the dosage and everything like that, because we're working with a company in the States that are preparing an application for an investigational new drug, so to put this CLN5 gene therapy through into a clinical trial. They are currently recruiting for a natural history study, and the idea is that if the clinical trial goes ahead, then these will be the children that will go into the study. So with our sheep that we have at the moment, they were all treated at 6 months of age, so at this kind of early symptomatic time point. They are all healthy in the field at the moment at 9 months of age. So we're currently following them every month, doing our clinical scoring, doing brain scans, eye tests, and everything else, and eventually we will look at their brains and their eyes and see what's happened there. And one really important thing about this trial is that usually we treat the sheep obviously with the sheep CLN5 gene, but we're also in this study have a cohort of sheep that have the human CLN5 gene. So this is the exact drug that will go into children. So we're sort of testing the safety and the efficacy in a larger brain for the first time with this human gene. So that's very cool stuff. So yeah, thank you.
Thank you very much, Dr. Murray. Hugely exciting research, so we're looking forward to more results. So the next research is going to be presented by Dr. Amanda Liver. This is an example of another sort of area where Cure Kids works, where we pick a particular disease area or a particular health challenge facing children, and we work with partners to see what can be done in that area. And so on this, we've teamed up with Child Cancer Foundation with support from the Lindsay Foundation to really enable a substantial program of research for children with rare cancers in New Zealand. And the idea is precision medicine, which Dr. Liver will tell you about, but it's really finding specific treatments for individual children. And Dr. Liver works with Dr. Siobhan Cross and with Dr. Andy Wood based in Auckland.
So I'll start with an apology. I'm not Andy Wood, who's the lead investigator on this study, and I'm a double sub for late notice, so if I stumble over a couple of slides, please forgive me. So Andy is our principal investigator for this project. So just a bit of background on paediatric cancers. Some are very similar to adult malignancies, but some are very, very different. And about 1 in 500 children will develop a cancer under age 15 years, which equals in New Zealand approximately 3 cases per week and 1 relapse per week. So overall, our cancer story for survival is excellent, with 84% being alive at 5 years from diagnosis, and that is on par with the countries we benchmark ourselves against, so Canada, Australia, the US. But that's not the end of the story, and benchmarks are one thing, but that's not good enough for a number of children. And part of that story is that when you look at medical deaths in New Zealand aged between 1 and 19 years, you can see there that cancer deaths are the most common cause. How we look after children with cancer in New Zealand is that there are 2 specialist cancer centres, one Starship Hospital in Auckland and the other CHOC, or the Children's Haematology Oncology Centre, located here in Christchurch. And the country is divided up with the South Island and the lower half of the North Island coming to CHOC, and the top half of the North Island being cared for in Starship. And one of our goals is that wherever you live, whatever your decile is, whatever your ethnicity is, that you receive the same quality of care. So what's our approach for most children? So first of all, we need to categorise their disease, and Andy's chosen a fragile handle with care box there because children are taonga and we need to look after them. And then we have multidisciplinary teams that make decisions. And the orchestra there represents, everybody. We've got doctors, nurses, allied health, pharmacy, play therapists, researchers, who all have unique roles to play in the orchestra, but collaborate to make the decision for that individual child and hopefully work in harmony as well. And then we use a proven treatment to treat the child's cancer. What if that doesn't work? What happens when a cancer doesn't respond to initial therapy or goes away and then comes back? It's much harder to treat in that set of circumstances. Oftentimes we've got a good plan B that we try, but sometimes not. And are there rational ways that we can use our knowledge to approach this situation? So what we know about cancer is that it's a genetic disease, that DNA carries the instructions for life, that you get your instructions from your parents, with a total of 6 billion DNA letters there. We know that mutations, which you might like to think of as spelling mistakes in your DNA, can accumulate, and this can lead to cancers, and cancer mutations can also evolve over time. So what precision cancer medicine is looking at doing is bridging the research sphere and clinical practice, and using tools such as next-generation sequencing to test hundreds and thousands of cancer genes simultaneously. So when this technology evolved, it's really, really expensive. For New Zealand children, a third to slightly higher, 40% of childhood cancers are treated on international clinical trials, and these trials provide access to the latest diagnostics and often medications that we use. And that's subsidised in New Zealand for these children. But precision medicine is expensive. And when it came online, New Zealand children were actually shut out of being able to take advantage of that. And this is where our wonderful sponsors, Cure Kids and the Child Cancer Foundation, came online to help us with that. With the Precision Pediatric Cancer Project, where the goal was to offer next-generation sequencing, in particular for those cancers that had relapsed or proved themselves refractory to our initial treatment, the hard-to-treat cancers, if you like. And again, this was set up to be a national project so that children throughout New Zealand could benefit from this, and that it would be equitable. It wouldn't just be available to those that could afford to pay for the testing. So the major aim of this project is to match a genetic mutation to a targeted therapy. So to take it from the lab right through to clinical practice.
So our old medications, cytotoxic chemotherapy, work by damaging DNA, damaging the cell division machinery, and they attack or work on any rapidly dividing cells, whether that be the cancer itself or healthy tissue. So it's a bit like firing a shotgun, where there's effects on other normal tissues that ideally we would avoid. Precision medicine looks to use a targeted therapy, which we've gone for rifles here, a sniper rifle, which can inhibit cancer mutations, has an effect on the immune system, and usually has less in the way of unwanted side effects. It's not often that we find the targetable mutation, but when they do, this is a young girl who was diagnosed with an epithelial myofibroblastic tumour, which is vanishingly rare. And when her family presented, they asked about what are the treatments, what have the outcomes been for other children. And at that time, there were only 9 reported cases in the literature, 8 of whom who had already died from their disease. So you can imagine that that's devastating news both to give to that family, but also to receive. Fortunately, this little girl has what was shown a couple of slides back here, an ALK mutation, which is known about in a particular type of adult lung cancer, and does have a targeted therapy known as crizotinib. And so she was started on that medication and is alive and doing well today. So what we get together is big multidisciplinary teams. We identify eligible patients at the 2 specialist paediatric cancer centres. They can have their tissue tested at the University of Auckland and also in Sydney. And this collaboration is allowing some leverage and synergies to grow both New Zealand's capacity in genomics, but also exposing the people involved in this research project to the processes that other laboratories are using, and developing national, consistent, standardised ways of doing the sequencing. And again, at no cost to families, providing equity for our children. We do have another issue that came to the forefront a few months ago, where our ability to look for these mutations does rely on us continuing to have access to the targeted therapies that are out there and available. And there was media reports that Pharmac may end our blanket funding of kids' cancer drugs, which will make things more difficult for us when we do find a targetable lesion if we're not actually able to access the medication for that target. So over the course of this project, precision medicine has evolved, and it's evolved fast. So Andy's team have had to pivot, take on new projects, and make what we were doing actually keep pace with what's happening internationally. More mutations in the cancer that are cancer-related have been discovered. Some of these are more complex mutations, which are harder to find and characterise. And also the epigenome, where the DNA letters are normal, but the regulation of the DNA is abnormal, is becoming more and more important to treating cancers. So it's making essential the genetic diagnosis. Some of the challenges that have evolved over the time of this project is that next generation sequencing is sometimes offered an alternative diagnosis in difficult to diagnose cases. So classically, we take some tissue, it goes to the laboratory, the pathologist looks down the microscope at it, looks at the size and the shape of the cells, where the tissues come from, does some special staining, and tells us what this cancer is. Sometimes that's difficult, sometimes things are undifferentiated, or they don't look like something, or it's like this is in the wrong place for what we'd expect that to be. So next genome sequencing, where we look at the actual genetics, can sometimes tell us that even though it looked like this under the microscope, actually this fits much better in a different set of cancer diagnoses and therefore requires a different set of treatment. It's also told us that a number of kids actually have an underlying genetic predisposition to cancer, which is important for that individual child, but may also have ramifications for other family members that can undergo surveillance screening for cancers. We also know now that next generation sequencing is likely to be a requirement for entry onto clinical trials that we run throughout New Zealand, and so we really need a platform where we can keep up with what's happening internationally and allow our children to be part of those clinical trials. And the epigenome is trending towards becoming a standard of care in a number of cancer types such as sarcoma and JMML. So the project's responded by looking at a much larger gene panel when we do this testing. There's an informatic pipeline that's been developed within New Zealand. We are exploring the epigenome, and we're currently working towards New Zealand's next generation sequencing becoming accredited so that we can facilitate our access to clinical trials and also drug access so that we can maintain what we currently have for children in New Zealand, which is the same survival data as overseas and also with no equity issues. So our goal quite clearly is to have more of this, where children who would otherwise die from their disease get an accurate diagnosis and, if available, get targeted therapy. But also recognising that while that might not always be the case for all children, we can confidently say to their whānau and family that we have done the best for them in using technology to look for these things, and perhaps they can take some solace in that there's nothing out there that their child is missing out on at this point in time. So we'd like to obviously thank Cure Kids for their generous support ongoing in this project. It really is going to make a difference to a number of children throughout New Zealand, as well as the Child Cancer Foundation and the Lindsay Foundation. Thank you.
Thank you very much, Dr. Iva. And this shows what we can achieve with these collaborations with a number of groups and our generous donors. I'm next going to hand you over to Professor Stephen Robertson, Professorial Chair in Dunedin. He works on genetic disorders, particularly in the skeleton and the brain. And as a busy clinician, he spends a lot of his time caring for those children out in the community, but also somehow manages to lead a research team of incredible people working to try to understand these rare diseases and to develop some solutions for children who have to live with them.
Thank you very much, Tara. It gives me great pleasure to talk a little bit about the kaupapa which we're following in my group in Dunedin, but my clinical activity is coordinated out of here in Canterbury, and really this is a national scale project in which we try to address the genetic underpinnings of diseases in children. So it's related a lot to what Amanda has just talked in terms of cancer, in that these are really an extended group of conditions which have genetic underpinnings. Surprisingly, a common scenario that one child in about every classroom in New Zealand has some kind of disorder with a strong genetic influence which requires heavy input in terms of their health care. And our mission in my laboratory in Dunedin is to improve the diagnosis and treatment of those children so that their management is optimised in full view of the genetic underpinnings of their conditions, no matter what the phenotype, no matter what the disorder. It's perhaps best to give an example to give you some idea about what we get up to and what dividends can arise, because perhaps genetic conditions have an undeserved reputation of being something that's fixed and not able to be addressed meaningfully in any way. These are two children that I came across in my life as a clinical geneticist. First, I met the older one, Charlie, when she was in utero, and her scan showed underdevelopment of the back of her brain. And I, at the time, thought this was actually a really non-confronting, non-progressive condition, which was unlikely to recur in that family, and I told her parents that. But as time rolled on, she was born and she grew up. It began to become evident that not only was this a progressive condition, but she was joined by a sibling who had exactly the same thing a few years later. And you can see the MRI scans there with the arrows pointing towards the hindbrain, the part of the brain which is involved in balance, which is severely impaired in these children and is progressively melting away with this condition, which I failed to diagnose, no matter spending a fair bit of the taxpayer's dollar trying to pursue a diagnosis for this family. So clearly we had something genetic, clearly something that was beyond my abilities as a clinician to diagnose, but the community, as shown in that article from the ODT, was right behind them and indeed built them an accessible house so that these children could continue to operate effectively within their community, go to school and operate as much as they possibly could. So we reverted to genome sequencing, the same technique that the cancer geneticists are using in Auckland, and together with colleagues combed the genomic sequences of that family, trying to find a blemish in there which was a misspelling which might explain their phenotype. And indeed eventually we did. We found that there were genetic defects lying in that gene, which goes by that acronym, that encodes actually an enzyme which had been described, and defects have been described in a very small number of children from across the world. But amazingly, what was implicated by this diagnosis was the fact that this defect was treatable, that we had the chance of actually reaching for something that you and I can buy across the counter at your average pharmacy, CoQ10, and treat these children with it. And indeed they responded beautifully and dramatically. We've arrested the progression of this disease in these two siblings. They remain going to school. They're intellectually normal, remain a little unsteady on their feet because of the pre-existing damage that's already happened. But this is an example of something where genomics can really be transformative, just as it was with the little girl that Amanda presented just before. So that was a diagnostic odyssey which took far too long. But really reflects the rarity of this condition, but also our lack of access to it and our lack of capability, at least at the time, to be able to use these types of tools here in New Zealand. But we've actually now sort of accelerated that program, and we recently completed a study of 51 families with similar types of presentations to those two little girls in the south. And we've made diagnoses where doctors using conventional approaches haven't been able to make them in nearly a third of these whānau. But not only that third were provided with answers, but there's actually an extra 12% where there are possible answers, where we're on the cusp of knowledge and where we might be, in fact are, describing and discovering new genetic conditions as we perform this research. And so genomics is actually entering mainstream healthcare aggressively and quickly. And we're up to the challenge, thanks to funding through Cure Kids. Big hurdles remain though. If you sequence your genome, all 3 billion letters of it, and type it out into books, that's the bookcase that you would fill, just as a single human being. And so as you can imagine, as we accumulate this sort of data in the hundreds of New Zealanders that we've now sequenced the genome of down in Dunedin, we're filling our servers up pretty quickly with a lot of data. Not only do we have that challenge though of performing analyses and making comparisons from human genome reference sequences across the world, we're also recognising that we have some genetic uniquenesses here in New Zealand because we're a Pacific nation. Now, other countries across the world realise that they've got uniquenesses too, but New Zealand is perhaps most acutely in a position where we are very unique in terms of the Pacific genomes which so many New Zealanders have. And we need to be aware of the architecture of those genomes and need to build a reference sequence just like these other countries are across the world. And I'm delighted to say that with the help of the New Zealand Government, but also Cure Kids, we've begun that task out of my laboratory in Dunedin, and we're coordinating a national project to do precisely this, to create a genome resource to serve New Zealand's children. Where might we go? Well, this is a story about growing up people. This is a cancer syndrome, which is nearly New Zealand unique in terms of its occurrence. And you might recognise Stan Walker, the rock star there, as one of the individuals from this whānau who actually has one of these cancer-causing mutations that runs through his whakapapa, and indeed led him to make the decision to actually remove his stomach before cancer took his life. So that's an example of a success story where genomics can educate healthcare quite dramatically. In paediatrics, with children, it can be just the same. This is a scenario of a family that we've still yet to crack. The disease which this whānau have, this iwi in fact, have is a rare liver disease. It should occur in 1 in 15,000 children across the world, but in this community it occurs in 1 in every 100 children. What is it about the genetics of that New Zealand situation which leads to this sort of outcome and leads to these children having to have dramatic surgery, if not liver transplantation, to save their lives? We would like to drill down on that and come up with those answers, if at all possible. So our mission to enhance the healthcare of children by using precision genomic medicine goes on. We're studying not just diseases of brain and bones anymore, we're spreading right across the paediatric sort of spectrum to try to bring answers for wherever they can be found using these sophisticated tools. And it's a big shout out and a big thanks to Cure Kids for nearly 19 years of staunch support for our kaupapa for New Zealand's children in this area of precision genomics and its application to paediatrics.
So thank you. Thank you to all of our researchers. Thank you to the University of Otago for hosting us today. Quickly say that as Vicky Cameron leaves. We're very grateful to be here. Thank you for the work that you do in caring directly for children, but also the work that goes on back in the laboratory, working with colleagues internationally, pouring through scientific papers. We are very grateful for everything that you do for children. I'd also like to say thanks for the voluntary contributions of people like our professorial chairs who also sit on our assessing committees and give us advice on the scientific decisions that Cure Kids makes. There's a lot of hours that goes into that, so we're hugely grateful to our professors. You can see why I love my job. It's pretty rewarding to be working in this field. And Francis and Amanda and Debbie and I love coming down to the South Island and seeing the incredible work that's going on at Otago, but also at Lincoln and at the DHBs and out there in the community. I would like to say particular thanks to Jordan today. Jordan is very passionate about what we do at Cure Kids. She's worked with us for a long time and achieved a huge amount. And I know that there are many of you in this room who really have enjoyed working with Jordan. So she's going to go and spend more time with her boy and do some study, and we're looking forward to staying in touch with Jordan. But I know Jordan would want me to say a huge thank you to all of our generous donors here in the room today. We know that you have fundraised and gone over and above bringing money to Cure Kids to support all of this incredible work. So we wouldn't be here without you, and please, pass this on to the people who aren't here today, the difference that they've made for the children of Aotearoa. Nō reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Thank you, and please feel free to stay on for a while and ask any questions of our researchers while we pack up the room. Thank you.